all, this is from January all the way through December. So you got 12 months. This is your average kWh per day for each month. And you can see the lighting energy usage, these little yellow bars, are pretty consistent throughout the year. But if you look at these blue bars in the middle, everything kind of looks blue in this graph at the moment except the top. You can see that these blue bars are showing more energy usage in the summer than the winter. This is your space cooling representation over here. So the model is telling us, not just what we're using in energy, but it's breaking out into pumps, fans, space cooling, space heating, ventilation, lighting, miscellaneous equipment. It's getting down into detail. Probably more detail than what the building owner and most people here want to know. But this basically helps us develop the baseline, then helps us identify and analyze what proposed measures we can do to save energy, and calculates that energy reduction and cost savings. From the model and the data collection, the results we get are in the form of energy efficiency measures. Measures can be building envelope, such as weather stripping or window film. Window film is great because it cuts down solar radiation on a building. It reduces your space cooling, and it's great. It works even great in conjunction with your cooling control system. So when you have less cooling in the building, your control system that's supporting that understands that there's less cooling and works more efficiently. We have measures such as lighting, upgrades and controls, occupancy sensors, just putting it on a schedule, going from T12s to T8s, or now LED lights are becoming very popular. Other measures include HVAC, equipment upgrades, so you can just plain out replace a chiller, replace a boiler, a cooling tower, something capital, or even a rooftop unit for air conditioning, replace your lights. Variables frequency drives, you may have heard this a lot, but this is a great application for motors and pumps on a building to let it operate at part load. And again, the model will tell you how much energy it's going to save. And this is a very lucrative measure in most cases. Retro commissioning. 70% of buildings these days do not operate how they're supposed to. They're designed and supposed to operate at a certain level of efficiency, but because of user error, changes in set points, things not being tuned up right, there is a lack of efficiency in the building just because it's not set up right. So what you need to do is go back and recommission it. And when you recommission it, change set points, tune up the system, adjust your controls, whatever it takes, whatever it's found through the retrocommissioning process, you will find that the building will save energy. Controls measures. It's a part of retrocommissioning, but it's also sometimes buildings just don't have controls, or they don't have adequate controls, or they don't have the appropriate strategies. So direct digital controls are very important for building controls. Energy management systems, EMS is a term that's often used, or building management systems. An example of a control measure is a CO2 economizer. This is just one of many measures used on your ventilation system. But you can reduce your space heating and space cooling by putting a CO2 sensor either in your zones or your turn air path. What that sensor will do is it'll tell the controller, if your CO2 levels are too high or too low. If they are too high, it'll allow more outside air to come in through a motorized damper on the motor on the damper. If it's low, it'll reduce the amount of outside air coming in, and thus cutting your space heating and cooling and dehumidification as well. So it does two things. It lets you maintain your indoor air quality, so you're getting the right amount of outside air you need, but it helps you optimize yourself on energy, so you're not letting an excessive amount of energy in. Excessive amount of air in. Night setbacks. You can raise your temperature for cooling or reduce your heating set points at night because you don't have as many people in the building. Common control measures. Now, once energy efficiency measures are made, there needs to be a decision. You're not going to implement everything. You got to do what makes sense. It's a business decision. So one thing is to know what's the scope of work. Identify the measures you want to do. What's going to help? What's the cost of these measures? What rebates and incentives are available? There are a lot of incentives and rebates available, and we'll talk about that in a minute. The energy cost savings, how much is your bill going to get reduced? How much of an impact does it have on the energy? How much of an impact does it have on the greenhouse gas emissions? Obviously, the simple payback period. How fast is that going to pay back? Key business decision. And you also need to consider remaining useful life. For example, if a cooling tower is near the end of its life, you may want to change it sooner, but change it also for something that's more energy efficient, because an old one that's near the end of life is probably not going to be as efficient as it was when it was new. And then there are newer ones with better technology, maybe an oversized one, maybe throw a VFD on it, and that replacement can both save energy and take care of a maintenance issue that you would prevent maintenance issues you would be having in the next few years, and take care of a capital upgrade that you're going to have to do anyways. In the audit, we're also going to find a lot of low cost or no cost measures. Very simple things, very simple fixes that'll help save energy. A lot of times that these measures alone will help pay back and pay for the energy audit. Here is an example of energy recommended measures, recommended energy efficiency measures. As you can see here, we've got the list of measures from lighting to controls to tuning up your package units. We have a cost estimate broken down here. The cost savings based on your kilowatt hour reduction or even your therms reduction. The estimated rebate from the utility or from the government. And then a calculation of payback. You can see some of these measures, like 7.4, may not be as good, but of course this one is also doing more than just energy efficiency. You're also changing the refrigerant. But then you got some measures like 1.6 that are pretty lucrative. You want to take stuff like that. We also have demand savings, kWh saved. In this case, we don't have any therm saved, but we do look at that. And here's an estimation of your greenhouse gas emission savings. So now that you've identified your measures, how are you going to pay for it? There are a lot of rebates. A popular website is called www.desireusa.org. This tells you about rebates for the electric company, from the gas companies, from the states. There are a lot of them. There's a lot in California, but there's a lot of out-of-state rebates as well. Tax credits. A popular tax credit is a federal tax credit called EPAC 2005. And what that does is it measures your building's performance after an upgrade in reference to ASHRAE 90.1 of year 2001. And based on that improvement, you can earn up to $1.80 per square foot. So if you have a 100,000 square foot building, that's a tax credit of up to $180,000, depending on how much you save. Another option is performance contracting. A lot of ESCOs these days, they work with you to basically pay for the measure through financing, but they earn through the energy savings. So essentially the energy savings offsets the cost of the financing. And another option is AB 11 PACE financing. This is a government bond that helps you pay for the implementation of an energy project. And once you've done that, the next step is to implement. I'm not going to go into implementation. It's a broad subject, but the things to think about is who's going to do it? Who's project managing? Who's your general contractor? How do you know if you're going to save energy at the end? Just because somebody doesn't work, how are you going to quantify that? Who's your energy consultant? Permits, things like that. Those are things to think about. And like I said, I'm not Tony, I'm Chetan. But if you have any questions, you can email Tony or call this number and reach me. Like I said, we'll have a question and answer session at the end of the panel.
My name is Ryan McAvoy, work at Guy.